This is a video guide for working with Landsat scenes in QGIS, specifically merging and mosaicing multiple Landsat scenes. And typically this issue arises when you want to create a project area that's relatively large that's going to span across several tiles, Landsat tiles or Landsat scenes. So to get started, we are going to go through several steps. The first step being organizing the project within QGIS, accessing the data from USGS, and then actually doing the merging or mosaicing process within QGIS. So first step here, let's go ahead and set up a project boundary. So in this case, I'm going to utilize the county, Harris County, for Houston metro region. So if I zoom into Houston here, I can see that I have a urban area with an OpenStreetMap base map here, and I'm just going to overlay the boundary itself. So you can see the county boundary gets most of the city, of the impervious surfaces, doesn't get all of them. Then I'm going to drop in the scene boundaries for each Landsat scene that is going to coincide or intersect with this particular project area. So more on this in just a second where I got it, but let's just talk about the formatting of the scenes first. So here we can see that the scenes are numerous, they're contiguous. If we zoom out a little bit, we can see what's going on here. So these are as Landsat spans the globe and collects information, it's collecting it in a very pre-formatted way based on a path and row formulation. So that's what we're looking at right here. So I'm just going to go back to my original scene here, or my original geometry. And what I'm really interested in is what coincides with this area. So 025039, 040, 039, and 040 over here on this side, they all correspond generally with this area. So these are going to be the scenes I'm interested in. There's basically 4 scenes here. Now before I go too much farther, I want to create a minimum bounding geography for this particular feature. So the polygon feature is relatively complex for the county. I want to simplify that because when we go get our imagery, our selection criteria needs to be as simple as possible. So the first step you want to do here is search for minimum geometries. You can just type in bounding. Okay, minimum bounding geometry is what you're after. You're going to input whatever the geometry is that you have for your quote project area, and we're going to select the bounding box, okay, the envelope, and we'll return that as a temporary file. And you can see it just gives us a simple geometry. What's advantageous here is that that geometry actually is slightly larger, obviously, than my input geometry for the county, and it spans across all the 4 scenes that I would be interested in. And the way that these scenes are identified is through a path and a row. So path 26, row 39, path 26, or 25, row 39, 2540, 2640. Okay, so we can keep an eye out for those particular path and rows once we get over to USGS. So before I do this, I want to export this out to a folder. So I'm going to export the bounding geometry as a shapefile. Okay, I'm going to make a new folder here just called bounding geo. And I'll put my feature that I'm going to call bounding geo inside and go ahead and save it. I need to zip that up. So I'm going to go to bounding geometry to the folder and send to a compressed zip folder. And then what I'm going to do is head on over to Landsat. So before we get too far along here, these are the Landsat mission tile delimitations with the IDs that I showed in QGIS. And what I'm really interested in here is the WRS-2, which is for Landsat 4 to Landsat 8. It's descending daytime that I want. So if I want to get this feature, I would just go to the Landsat missions, shapefiles and KML files. And this will give me a shapefile or a KML file that I can bring into QGIS that will give me the outer extent of each one of those tiles, which was the magenta color. So if I go back here, that's the magenta with the tile description. We can also use a utility called Landsat Look. So if we go into USGS Landsat Look, this gives us a preview, a scene preview, and I can just type in a city here. In my case, I'm interested in Houston. Okay, there's Houston. Brings me to that location. And then I can click on scenes and I can get a sense of where those scenes are located, how many of them are intersecting with my project area. Okay, so this can be a really helpful sort of preview of my potential scenes. And there's some variables that you can adjust here. Where most of all this work is going to happen is in Earth Explorer. So if I click on Earth Explorer here, it's going to bring me to USGS Earth Explorer. You can see that I'm currently not logged in, so I need to create a login. So I'm just going to pause the video here for a second and log myself in. Okay, so I'm logged in. You can see myself logged in up at the top right-hand side here. If you are visiting Earth Explorer for the first time, you'll need to create that login. So the first thing we want to do under search criteria is upload the shapefile that we just created in QGIS. So I'll go to shapefile, select the file, and I'm going to point it to the zip folder and say open. So it comes into Earth Explorer, and we can see it shows the minimum bounding envelope, which is exactly what we want. Now we're going to head over to further criteria. So we got our initial search criteria. I'm not going to do date range and cloud cover right now. I go to datasets. I'm interested in Landsat, so I'm going to click on the Landsat tab. And I'm interested in the collection 2, level 2, which is an enhanced product. And I'm going to click on the Landsat 8. So I'm interested in the Landsat 8 mission. I could get 7. I could even go down to 4 or 5 if I want to go back in time. And for additional criteria, here's where I'm going to set up a cloud cover criteria. So I'm interested in making sure it's relatively cloud free. So I'm going to go to 0, and my threshold is going to be at 10%. You can have a different threshold if you want to be a little bit more permissive, maybe up to 20%. And we go ahead and say results. And what it's going to do now is give us some previews on the left-hand side here, importantly with the path and the row numbers. Okay, so I know what my path and rows that I'm interested in. I can also click on the little footprint here, and it's going to show me the footprint of my scenes, which is really helpful. So we can see that we got, let's see if we can get that bottom one, which is 2640. That's this one right over here. So there's 4 scenes that I'm really interested in. Since I've already put on a search criteria for cloud cover, I know that what I'm getting returned back here is relatively cloud-free, which is great. And we can see that these are pretty cloud-free scenes, even in the little preview on the left-hand side. So at this point in time, I have basically the criteria set up. These are relatively recent, so it's going to give me my most recent first. And we can see we have lots of options in 2021. So the first month of 2021, I have a lot of options. In the third month here, and in the second month, I have some options. I probably want to stick with the last couple months for my final mosaic. I want to make sure that I'm not going too far. My temporal range is not stretched out too far. So comparing something that was 8 months ago to now, you probably want to avoid that and see if you can get your scenes within 1 month or 2. So your temporal resolution for your mosaic should be really constricted as possible. Ideally, we would have a tile at the same time and the same date. Everything's exactly the same. But since we're mosaicing these together and putting them together, we want to make sure that the parameters are as consistent as possible between each one of the scenes. We're not going to be able to get it right on the dot, but we want to get it as close as possible. Okay, so the next thing I need to do is actually go ahead and download this data, and there's some different options that we can utilize to download the data. So our second stage, after we have our bounding geometry, we have a series of scenes that are potentially available for our particular location, for our particular bounding geometry. We can go ahead and start to do the download process. And when we download, we have several options here. So if I click on the icon that shows the green down arrow, download options, for whatever scene I'm interested in, it's going to give me download options, product options. As soon as I click on that, I can download everything, which is a pretty large file size. So in this case, it's going to be 920 megabytes, or I can go to the actual individual bands themselves. So what we want to do is make sure that we have our correct scene. So I'm going to click on a foot path here. I know that I want this one, so let's go ahead and do this one. So this is going to be 2639. I'm going to go to download options, product options. In this particular demo, I'm just going to composite or mosaic, not composite, I'm going to mosaic band 3. Okay, so for each one of my tile scenes, I want to just isolate band 3. Okay, so for instance, if I wanted to just composite band, say 432, I could go ahead and do just band 4, band 3, band 2. If I wanted to do another band combination, maybe 5, 4, 3, I would get band 5, band 4, band 3. Okay, and I'd have to do that for each one of the scenes. for this demo, I'm just getting band 3 in this case. So I'm going to download band 3. Okay, so it's going to start the download, and it's 84 megabytes. So that'll take a moment for it to get situated and start downloading. I'm going to go ahead and pause the video and move along to the next scene. Okay, with the first TIFF file downloaded, I'm going to move on to the next scene. So I'm going to click off the footprint for that scene. This can get a little confusing here. Let me make sure my scenes are toggled off. Okay, I'm at 2640 now, so I'm going to go ahead and download 2640. And remember, I'm just downloading the band number 3. So we can see that it's the tile identifier and then underscore B3 for band 3. Okay, and then I download band 3. Okay, 2640 is downloaded. I'm going to go ahead and toggle off that. And then I also need to do 2539. So again, I'm going to point it to band 3 and download the product. Okay, and again, it's going to take a second. So I'm just going to go ahead and continue on until I got all 4 scenes. As soon as I have all 4 scenes, then I'll go ahead and preview those in the drive before I bring them into QGIS. Okay, I've downloaded all my band 3 scenes at this point, and I'm going to go ahead and head back to QGIS. So the first thing I want to do is preview my scenes. So here's all my band 3s. And I can see that I have 2539, 2540, 2639, and 2640. So I have all the bands that I'm interested in. Let's go ahead and import these. So I'm going to go to my data source manager, point it to the raster file types. I'm going to go into my band 3 folder that I created. Whoop. Let me go back there. And I'm going to go ahead and select each one of these tiles and say edit and close it. And we can see that they match up right with the paths we would expect, the WRS2 descending path order. So at this point I have a composite here of, well, I don't have a composite yet. I have multiple tiles that are just sitting within QGIS that are overlapping each other in various ways. So what we need to do is we need to now go ahead and do a merge process. So I'm going to go ahead and click on the first one. So this is 2640. And then let's click on the adjacent tile, which is 2639 right above it. And we can see that there's a visual difference between the tiles. Okay, so if I zoom in, we can see that this one is sitting on top and there's a overlap here. So let's zoom back out. And there's actually quite a bit of overlap here. So this bottom scene overlaps onto the top scene a significant distance. Okay, so what we need to do is we need to specify how are we going to bring the overlapping cell values into the final composite. Okay, let's do a quick test here. Let's use our value tool. So I'm going to click on the value tool here, and I have 2 tiles that are up and running right now. And if I zoom over these, we can see that the tile values are very similar between the 2. So if I click on this particular cell right here, one is 97777, and then it's 9749. Remember, I was collecting on different dates. So there's going to be a slight difference between these 2 products. Okay, but they're representing the same features. So the range here is going to be relatively similar. Okay, so this bright pixel is always going to be bright. So it's always going to be pretty close in value. Okay, so that's the criteria that we want to meet. We want to make sure that we have at least similar values. And we need to understand the relationship of these 2. Let's go ahead and bring in the other ones also. So we bring those together. We got 4. Let's click off the top one. And we can see we have a fair amount of overlap down here on the bottom. And then also this scene sits on the bottom and has a fair amount of overlap too. Okay. So what we need to do is go ahead and start the process, the mosaic process now. So how do we do that? We have, we've met the condition where we have all the bands are of the same band number. So they're all band 3. They're all consistent in their path and row. They're right next to each other. So they're creating the larger project area. They're inclusive of the larger project area. So we can go ahead and begin that process. One thing that's important, though, that we need to realize is that even though we have visually these products are sitting next to each other. In terms of their actual map projections, they're going to be projected into UTM. They potentially can fall into different zones. So in this case, I have zone 14 north. Okay, that's for the first tile here. This one's probably going to be zone 14 north too. Okay, that's all good. However, if I go to the tile next door, I'm at zone 15. So if I were to mosaic these together, they're sitting in different projection systems, the ones on the east versus the ones on the west. So what I need to do is I need to make a decision to have all these consistent within the same projection system. To get started on the third and final section or stage to actually create the mosaic, we need to first reproject into a common coordinate system. So if we go take a look at our bands under properties and go to source, one's at 15 north UTM, another one is 15 north, 14 north, and 14 north. So they're not in a common UTM system, unfortunately. If they are in a common UTM system, you can go ahead and just start the mosaic process. That's perfectly fine, but you do have to meet the condition where you have all scenes that you're going to mosaic in a common projection system. So when you have multiple tiles that are out of sync with each other in terms of their projection, what we can do is just export them out to WGS 84, okay, to a geographic coordinate system, which is what we'll do here. And the good way to start this is just simply to start a new project. So what I'm going to do is just make a quick new project, discard everything, and I'm starting out in WGS 84 right now. So we can see over in my right hand corner it's EPSG code 4326, which is exactly what I want. And what I'm going to do here is go ahead and start to import those raster layers. So I'll go ahead and import the first one. And just bring all these in and say add. And it snaps it to whatever the first layer was that came in. So let's re-snap this to WGS 84. So I'm going to apply it and say OK. And you can see it stretches the tiles just a little bit when it's in EPSG 4326. So what we're going to do now is go ahead and do what's called a warp, or reproject the rasters. So to do that, we go to projections under the raster tab and warp. And we need to make sure that our parameters are correct. So I'm going to go from the top to the bottom. So the first one here is going to be 2539. Okay. And the resampling method is important. So we have several different types of sampling. Each one has its positives and its benefits. Sort of a compromise is called bilinear. Okay, so I'm not going to get into how the resampling method treats the cells in this video, but for Landsat, I'm going to go ahead and stick with bilinear as the resampling method, because what it has to do, it has to go in and look at the cell value as it makes the transformation. And my target CRS is going to be the project. Okay, so the current project is in WGS 84. Okay, I'm not going to set the source, I'll just have that be what it is currently coming in. Okay, and I'm going to go ahead and export this out as a reprojected file, so it's going to be as a geotiff. And I need to kind of keep track of my numbering here. So this one's going to be, well, I just forgot what it is that I have put in, so let's go make sure. So this is 2539. So I'm going to 2539 it. Save the file is going to be 2539 underscore WGS 84. And I'll say save and run it. Okay, that's going to take a second to run, and it'll stick it into WGS 84. Okay, I'm just going to go ahead and do the same process 3 times over, and pause the video, and then we'll go ahead and start up the mosaic process in the back end. Okay, at this point, all my input Landsat scenes have been reprojected or warped, and I'm just, to be on the safe side, I'm just going to start a new project here. So I'm going to discard the current one and load up my tiles one more time, and I'm going to point to the reprojections that I just made, add those all in. Okay, so I have the condition met where everything is in the same coordinate system. Go ahead and put in a background image so we have some context. All right, so what we want to do now is we want to start the process where we do the mosaic. And we can see that there is visually some difference here in terms of cell values. So let's just kind of check this out. So here, I'm in the top tile and there's no data there. So I'm comparing 2639 and 2640. So let me get a little bit closer. So let's just take this cell right here. So if I toggle on, toggle off right here in this particular location, we can see the 2640 is 9799 and the 2639 is 9776. So there's a little bit of a cell difference value there, but it's not really significant, relatively speaking. I mean, it's a pretty small value change. Let's check another one. So if I come over here to this cell, I have 2640 on the top, okay, and 2639 underneath, or I should say 2639 is actually on top. I think these are grayscale. It's hard to figure out what's going on. Okay, so 2640 is on the bottom, 2639 is on the top. Let's sample this one right here. So I have 11464 and 11254. Okay. Importantly, they're still a relatively same in terms of visual appearance. Okay, and since I'm going to be utilizing this mosaic for image classification, I don't have to be right on the cell value. I just need to be able to see the cell color combinations as I'm doing classification. Okay, so there's a little bit of difference there. All right, and our resampling method, how we actually do the resampling, is going to impact those resulting cell values. So what we're going to do here is go ahead and start the mosaic process. So we have all the conditions that we needed. We're going to go to raster, and there's a couple different ways to do this now. One way is to do a merge or build a virtual raster. So I'm going to do a merge process. You can also do it through build virtual raster. Let's just preview that. So here you input the elements, you determine who's going to take priority in terms of the resolution, and you can also do a resampling method here and produce a file, or we can simply do a merge. So I'm going to go to merge, and I'm going to input the layers, and these are going to be my reprojections. Say OK. The output cell type, we need to go make sure that we know what that is. So let's go to one of our layers. So I'm going to go properties, and I'm going to go into information, and I'm an unsigned integer here. Okay, so I'm going to stick with unsigned integer. So go to raster, and we need to merge it. Okay, so we're going to input 1, 2, 3, 4. All those come together. I'm going to have a unsigned integer as the value. Keep the defaults here. Merged, I'm going to save it as a file. So this will be, let's just call it Houston merge. That's spelled incorrectly. Okay. That should work. So let's go ahead and run this. And doesn't like that as a file name. So let's go try something simpler. Let's just call it Houston. And let's run it. Okay, it's going to take a moment to do the merging. Actually, went pretty quick. And let's take a look and see what we got now. Okay, here's our merged file. So we can see, if we look real closely, we'll see a little bit of a residual color difference here. But importantly, when you're doing your image classification, if you're interested in this area right here, it's pretty obvious that you have continuity. Okay. So there's the old layer, and you can see where the seam was originally. So let's go ahead and zoom to layer on Houston. And there is our merged mosaic layer. On the outside here, we have no data, so there's basically a value of 0 where there's black. Okay. So we probably want to go ahead and clip this down to a custom area now, because we're not going to be interested in certain parts of the mosaic results. So what we'll do before we get into any type of image classification is we would go ahead and go get probably the most inclusive geometry, which is the bounding geometry, and add that in. Add it in as a raster. Okay, add it. And I can go ahead and clip or mask this raster layer now. So let's go ahead and do that. So we go to raster and we want to mask. So we're going to clip raster to mask layer. And the input is going to be our Houston. The mask layer is going to be the bounding geography. And the target CRS, we can just have it be the WGS 84. Keep the extent, keep the resolution of the input raster at 30 meters for Landsat. All that looks good. Let's go ahead and output data type is going to be the unsigned integer input for the data layer. And let's go ahead and save this as clip Houston. See if that will run. Okay, we can close it, and yeah, we should be ready to go now. So this will give us a nice result to then go ahead and run some type of image classification scheme on. So we got most of the county. All right, we should have all the county actually. Let's drop in the county just to make sure. So the county boundary was here. We add that and close it. And we have a nice Mosaic base, Landsat base for band 3 for our project area. Now we probably want to go ahead and do the same process for 2 other bands that we're interested in combining with this band. So if I'm using 3 right now, maybe I'd want to do something like a 5-4-3 band combination. I would need to go back and get band 5 for the 4 original scenes and band 4 for the original scenes. Do the same process over again and then combine these together. And then I would have a composite Landsat image that I can either just display or I could go ahead and do some image classification work on top of. So this hopefully is a good overview for those situations where you have Landsat scenes that are covering a project area, but the project area is split between the Landsat scenes. It doesn't happen oftentimes, especially when you're working with larger scale geographies, but when you're working with something, say, the size of a county, a region, a province, you typically get into the scenario where you need to bring multiple Landsat scenes together, and we do that through that merge or mosaic process.